Welcome back, everybody. I assume those of you that are more astute realized that if we know how to convert between mass and moles, and we know how to convert between moles and particles, Mr. Diamond is probably going to make us have to convert between mass and particles. Because that just seems like, he's a jerk and wants to make us do a bunch of really difficult math problems. That's probably where this is going. And if you thought that way, ouch for calling me a jerk, but you are correct. That is where this was going. As we had mentioned before, moles is the central conversion point of chemistry. For now, you only have two ways going to moles, but we are going to be adding a couple of more things to that before the end of the year. In fact, there's going to be at least one more thing this chapter. Some of you may have noticed why. With moles, you can convert between particles to mass or vice versa. Like I said, we'll have other things that we're going to talk about later this year and even this chapter that we can do with moles. But this is kind of your intro to why moles are kind of a big deal. So this is a handy-dandy flowchart. You can freeze the video if you want to write it down. I think it is probably a pretty helpful thing for you to have to be able to help work through these problems. So when you're thinking about your conversions, you think about what you want to get to and where you are at. So if you have grams, for example, let me switch to my cool pointer thing because I know I have that. If you have grams and you want moles, we can just follow this purple arrow down here, and you can divide by the atomic or molar mass. Now, if I switch to my hand cam really quick, just to kind of represent what this is actually talking about, what it's saying is if you have like some number of grams of an element, it's saying you can divide by the atomic or molar mass. And that makes sense because you would have whatever your grams in 1 mole from the periodic table would be over here, and you'd end up just dividing by grams. So I don't want you to think just because that flowchart says you just divide by it. You still will need to show your work in dimensional analysis, and you will see why when we get to the next section that it is very important that you do that. Okay, going back to desktop. So if you had grams, you can just follow this arrow, and it tells you the path that you should be taking. Same thing if you have, let's say, atoms or molecules, which again are particles. If you have these particles and you want to go to grams, you can just follow, okay, I need to go purple arrow, and then I need to go red arrow. I need to divide by Avogadro's number. That'll convert me into moles. And then I need to multiply by the atomic or molar mass. That will give me the grams. So this flowchart is pretty useful. I will end up giving you another one at some point later on that you can use that's a little bigger and has a couple of other branches going off of it. But we'll worry about that when we get there. For now, though, we're just going to jump into our 2 example problems. First example is how many particles are there in 325 grams of potassium iodide? And then how many grams of gold 1 sulfate do you have if you have 4.35 times 10 to the 23rd particles? So switching back to hand cam, we can actually start working this out. We'll start with our first example because it was the first one, so that's how we're going to start. So what we need to do is we need to figure out what potassium iodide is. You've realized probably that this is now kind of the first step of a lot of these problems. So potassium iodide, potassium is K, and then iodide. That ends in IDE, and IDE is used whenever you are working with a single element, unless it's cyanide or hydroxide. So what single element sounds like iode? Well, that would be iodine, and iodine is just I. What charge does K have? K has a +1 charge, or a 1 plus. What charge does I have? I has a 1 minus. I has a 1 minus. No, the iodine have a 1 minus. I don't has any 1 minuses. So we can cross our charges. Moving on from that terrible pun. And we'll just get Ki. So Ki is potassium iodide. You might actually remember this is the substance they used in the elephant toothpaste experiment. This is the catalyst that you use to make it go really, really fast instead of yeast that you will have to take advanced chemistry if you want to see me use in class. Okay, and then we have 325 grams. So 325 grams of Ki. You'll notice that I did not immediately solve for the mass of Ki. And the reason for that is, I mean, you guys know at this point, because it's an example problem, you're probably going to have to do that. But we had problems where you just used Avogadro's number and you just converted and you were done. So you want to make sure that you need to do that before you waste your time and do all that work and then look at the problem and realize you don't need it. So this says I have grams of Ki. Can I go directly from grams to particles? No, I cannot go directly from particles to grams. That is not a conversion factor that we have. So I'll have to stop somewhere in between it. And as we just discussed, the main stopover point is moles. So we're going to put grams and we're going to put moles. If I haven't mentioned it, by the way, MOL is the official abbreviation for moles. I know that doesn't seem like much, but little m is meter, and it also actually means something else in chemistry. Big M means something else in chemistry. So MOL is basically you get one letter off. Okay, so to do this conversion factor, we are going to have to do this, but let's just make sure that this is going to be the right path. Let's make sure this actually gets us to what we want. Can we go from moles to particles? Yeah, we do have that conversion factor. So we can go from moles to particles. In this case, you could actually use formula units or FUs, but if you're worried about writing FU on your paper and them thinking that you, like your parents thinking that you hate me or something, you can just write particles. But this would be a formula unit, an FU. So we are going to have to find this. We already know this piece, though. So we might as well plug it in. 1 mole has 6.02 times 10 to the 23rd particles. Avogadro's number. But we do need to figure out grams, so we're going to kind of over here off to the side. We're going to solve. We have a K and we have an I. We have one of each. Now, this one's so simple, you probably don't actually have to list out all this stuff. You just do this plus this, but I'm going to be consistent and show you the long way every single time. So K is 39.10, and I on the periodic table is 126.90. I paused to act like I was looking it up, but I have them all. I have them all already written down on a sheet of paper. So I am a hack and a fraud. Don't trust anyone. So we're just going to add these two together, though. And if you add those two together, which I did not do ahead of time, so now I as I tell you not to trust me, I then show you me doing the work actually in the problem this time. All right, we get 166. But remember, when we're doing this, we do actually want to write 0.00 because it came from the periodic table, not that it's going to affect anything. And this is a grams per mole number. So we're going to put 166.00 grams are in 1 mole. Notice that moles has a 1 in both of these conversion factors. The only time currently that you can have a number with moles is if I give you the number in the problem. There will be one other case where moles will have a number with it, but I will save that because it's when we get to advanced stoichiometry, which is going to be the next section of this chapter. So we'll make sure we can crawl before we can actually walk. Just to double check, grams cancel, moles cancel. I'm left with particles or formula units of Ki. That is what I want. So we're going to go ahead and do 325 divided by 166 times. And because this is in scientific notation, I would recommend putting it in parentheses. I am confident enough that I know it won't screw up this time if I don't. So I am not going to put it in parentheses. But when in doubt, you should always put your scientific notation numbers into parentheses, just so that way they don't throw everything off. So now I get this really big number, but before we write it down, let's think of the same mental exercise and hit random buttons on our calculator as we awkwardly try to move it. I got 1.1786 times 10 to the 24th. Does that number make sense for particles? Having a gigantic number for particles. And the answer is yeah, that does make sense. Particles are super duper tiny. There's hundreds of billions and billions of them, even in something as small as like, a pencil lead that you have. So it does totally make sense that there would be a very large amount of particles that you're dealing with. So we're good with that number. Sig fig wise, 325 has 3. So we're going to do 1.1 and then 8 rounds up. So it'll be instead of a 7, 8. times 10 to the 24th. And now it is FUs, or particles, of Ki. Don't forget the unit. Don't forget the sig figs. All right. We're going to move on to the next example. If you have any questions for this one, again, just email me or put them in the box to the side. For our next example, we want to know how many grams of gold 1 sulfate are there in 4.35 times 10 to the 23rd particles, which I just scribbled off here, but that says particles over there. So let's start with that number. So we've got 4.35 times 10 to the 23rd particles. And we've already run into the problem because we don't know what gold sulfate is. So what is the symbol for gold on the periodic table? If you look around for a G, you will be out of luck. There's germanium and gallium, but there is not really a G. So it is because gold is Au, auric, is the Latin term for gold. So Au. And then it has a Roman numeral 1. So that means not a little number. That means that it has a 1 plus charge. And then we've got sulfate. Sulfate is another polyatomic. You can tell that because it ends in an ATE. It doesn't end in an IDE, but it sounds like sulfur, so it's probably got that. It's a polyatomic, so it's probably got O's. And then you just stuck with, okay, well, how many O's and what charge does it have? I'll give you a moment to hopefully remember that. And it is 4 and a 2 minus charge. Cross our charges, we get Au2SO4. Now again, you could solve for the mass right now, but we don't want to do that unless we absolutely have to. You want to save as much work as you can and try to do as little as possible. As I've told you many times, I'm incredibly lazy. I will not do work unless I have to. So let's just make sure we need it, because we might not. Spoiler alert, we will. But we might not. So this is particles of Au2SO4. Can we go directly from particles to grams? No, we cannot. We do not have the conversion factor. Can we go from particles to something that makes us closer to grams? Yes, we can go from particles to moles. And that is because for every 1 mole, there is 6.02 times 10 to the 23rd particles. Or in this case, this would actually be another FU, another formula unit. Can we go from moles to grams? Yes, we can go from moles to grams, but to do that, we are unfortunately going to have to work out the mass of our little gold buddy over here. So our particles would cancel, or our formula units would. Our moles would cancel. We'd be left with grams of Au2SO4. So we've got to fill in this number. So Au, S, and O is what we've got. We've got 1 S, 4 O's, 2 golds. And now we're going to fill in these numbers. I already told you earlier that I lied to you and already have these written down. So 197.00, sulfur is 32.06, and then oxygen is 16.00. Just like last time, though, I don't actually have the rest of this worked out. We can use 32.06 because it's just 1. 16 times 4 is 64. If you need to use a calculator for that one, you're good. And then this one should be like 394, I believe, but we'll double check just in case. So 197 times 2, 394. Heck yeah. For advice on doing quick math like that in your head, this is just 3 less than 200. So I just subtracted 6 from 400, and that's how I got that number. So if you don't think that I'm just like a crazy like math genius person, you can just do some shortcuts like that. So 394 plus, if I get this on screen, plus 32.06 plus 64. And we get 490.06. So 490.06. Again, we don't actually have to worry about sig figs for this part because we're just always going to 2 decimal places. This is an addition, and addition, you go to the lowest number of decimal places, which is always 2. So we're going to take that 490. That is a grams per mole. So we're going to put 490 with our grams, or 0.06 with our grams, and that is per 1 mole. Now we can plug in our calculator. This time, you have to plug this in using your parentheses. I'll show you again what happens if you don't, just to make sure that we're all on the same page, but you have to put them in this time. So 4.35 times 10 to the 23rd, close parenthesis. So that's going to be parenthesed off, divided by new parenthesis, 6.02 times 10 to the 23rd, close parenthesis. Now we're going to multiply. This one doesn't need a parenthesis. 490.09. Sorry, 0.06. Math is hard sometimes. And we'll hit enter. So I got 354. Does that number make sense? Well, we're dealing with grams. 300 particles would be really kind of small. 300 moles would be a lot of stuff. But 300 grams, if you think a gram is actually about the weight of a paperclip. So this is like, it could be, I don't know. I'm just trying to find something on my desk that would weigh like, that many grams. Like, I don't know, this cat hairbrush might weigh like 300 or 400 grams, 354 grams, whatever this number is. So yeah, like 300 grams of something, that makes good sense. I was petting my cat earlier, by the way. I don't use that brush for me. That is a cat brush. So please don't start rumors. So yeah, the number makes sense. And then for sig figs, we have 4.35. So we're gonna, even though it's gonna feel a little bit weird and like the answer's a little bit off for it, because our number originally was not super precise, we have to report our answer as 354 grams of Au2SO4. All right, I hope that helps this make a little bit more sense. If you have any questions, as always, you can put them in the box to the right, or you can email me. I do want to also, in this video, let you know that so all of the worksheets, the ones that involve mole to particle, mole to mass, and now this one that has them all combined, I'm going to have these be all due with tomorrow, which should be Friday if I've done this correctly, Friday's daily log. I assume most of these will go pretty quickly, but I'm going to make that one a slightly longer time for it to be due. You've probably noticed by now that all of the stuff is due kind of Sunday at midnight. I think that's probably going forward going to be how I do most of these. In this case, I'll give it a little bit longer of a time frame for you to get it finished. Some people still seem to be struggling a little bit with making sure they know when this stuff is due. This is obviously a completely new thing, so if you have ever like any questions or anything and you get stuck, just email me, let me know. I'll help work it out with you. I do also want to give an update that I do believe what I'm going to have you do is I'm going to have you send me a picture or a scan of your test. I can't currently think of a better way to do it because I really wish you guys could all like mail them to the school or drop them off at the school or something like that. If you have an easy way of like you have a family member that's going to the school, you can have them like leave it in my mailbox. That would probably be like the easiest thing because then I can grade it a lot easier. But if you can't do that, I would start right now just trying to find a way to scan your test sheet or get really good pictures of it, just so when I ask for them, you have them. Just trying to keep you guys kind of in the loop and ahead of the game. So I hope that helps. If you have any questions, like I said earlier, email me or put them in the box to the side. Hope you guys have a great rest of your day, and I hope to see/hear from you soon.